All right, hello and welcome back, everybody. In this video, I'm going to be talking about the derivative of tan x. So this is kind of like the third part in our short little series on proving the derivatives of each of the trig functions, so just finishing things up. So essentially what we are wanting to show today is this little diagram here that if you have the graph y equals tan x, the derivative of that, which is the gradient of that, is given by the ratio 1 over cosine squared x. So as you can see, looking at this diagram, that graph there in red is the graph of y equals tan x, and you can see everywhere along each of those curves, the gradient is in fact positive, and it is steeper over here. So it's more positive over here. It's also steeper over here, and it's at its lowest steepness here, but it's always positive. So this is kind of like the minimum steepness. So therefore, that's the minimum on this graph here. And by the same token, so the minimum steepness on the red curve is the minimum graph of the derivative, which is the gradient. And as the gradient gets steeper up here, you can see that the derivative of that, which is the gradient, is a more positive number. So that's what we're proving. So here is our objective. We want to prove that the derivative of tan x is equal to 1 over cosine squared x. So let me just get up the trusty stylus and we'll prove this real quick. So here it is. So what we've looked at so far is a couple of different proofs. So the first thing that we proved was the derivative of sine. Second one we proved was the derivative of cosine. For this particular one that we're going to be looking at today, we need to recall a couple of facts, which is that tan is equal to sine over cosine. And also, this is something that we haven't looked at in class yet. It's called the quotient rule. I might actually prove it in another video. But this is where if we have a function that is comprised of one function divided by another function, we can use this rule here. We can also write it as v times the derivative of u minus u times the derivative of v divided by v squared, where v is the one down the bottom and u is the one up the top. So we'll look at that in a minute. Now, of course, for this video, we also need to use the facts that we've proved last time, which is that the derivative of sine x is equal to cosine x. We proved that in the first video, and in the second video, we proved that the derivative of cosine x is equal to negative sine x. So we're going to use both of these facts. So let's give this a shot. So the first thing we're going to do is we're going to start out, we're going to say, let f of x equal tan x. That's the thing that we want to derive. And we want to show, so we're going to start out with the derivative of x. Now, of course, the derivative is going to be given by, like the limit definition that we know and love. Of course, in this case here, we could also recall, in fact, before we move on, that tan x is, in fact, if we look at our first identity here, it is exactly equal to sine x divided by cosine x. And of course, we've learnt this in class. You guys should be familiar with this identity by now. So if we accept that tan is equal to sine divided by cosine x, and we look at this as we're trying to find the derivative, so we want to find dx, so we want to find the derivative of tan x. Well, of course, this is just going to be equal to the derivative of sine x divided by cosine x, because tan x is sine divided by cosine, right? Now, what we can see here is we're taking the derivative of one thing divided by another thing. So we need to therefore use the quotient rule. And again, we'll look at this in chapter 6, so don't worry about it right now. But if we just define the upper function here as u and the lower function here as v, we can then apply this rule for the quotient rule, which we'll look at. So the rule says that the derivative is equal to the one down the bottom, so v squared. So in this case, what's the one down the, v. So we'll look at this. V u dash minus u v dash over v squared. So the bottom one is cosine x. So v times u dash, which is going to be the derivative of u. So what's the derivative of the thing up the top? Well, that's nothing but cosine x as well, right? So the derivative of, so again, I'll do this in blue, that there was u, that there was v dash. So other way around. The first one was v, second one was u dash, the derivative of the top thing. And then we want to subtract off the top function, so u, so that's going to be sine x multiplied by the derivative of the thing down the bottom. So the derivative of the thing down the bottom is negative sine x. Okay, and again, what we have done there is we've gone the derivative of the thing down. Sorry, we've subtracted off the thing at the top, which is u, and multiplied that by the derivative of the thing down the bottom. And we are going to divide all of that according to the quotient rule by v squared, and here v is cosine. So we have cosine squared down the bottom, and that is v squared. So I've just done in blue just to try and show you what I've done here, but yeah, that's the idea. Now we can kind of neaten things up a little bit with this this quotient rule. So this is going to give us cosine squared minus, well, actually, that's a double negative, so that becomes a plus sine squared x, all divided by cosine squared x. And look at this, we can see up the top here, we've got cosine squared plus sine squared. We know based on the trigonometric identity called the Pythagorean identity, that cosine squared plus sine squared is equal to 1. So we have shown what we want to show. Okay, so that's the objective. We've shown that the derivative of tan is equal to 1 over cosine squared x, provided that you understand what the quotient rule is, and also you know these trig identities. For example, that we know that cosine squared x plus sine squared x is equal to 1. Provided we know those things, we can show this quite straightforwardly. All right, and also provided that we know these other derivatives, which we've already looked at. Now, we now show that d dx of tan x is equal to 1 over cosine squared x. Okay, so what else can we do with this? Well, there's a few more ways that we can actually write this expression here. So one thing that we can use is we're going to recall, and this is something you might not have seen before, but we've got a special name for the ratio 1 over cosine. This is actually called secant. So we define 1 over cosine x as secant x. So therefore, this thing here, the derivative of tan, could be written as sec squared x, so the sec squared, or sec x squared. Also, we can also use another fact. So I'm also going to recall that, okay, if we use this identity that we had before, so we know that cosine squared x plus sine squared x is equal to 1. What we can do with that identity is we could just look at that, and if we divide every single term in that expansion by, say, for example, cosine squared x, something kind of interesting happens. So we take this expression, we divide everybody by cosine squared x to make sure that both sides of the equal signs remain the same. We're going to notice that, well, have a look at this. Cosine squared x divided by cosine squared x, provided that the thing down the bottom is not equal to 0, this thing is equal to 1. And this guy here, well, that's sine squared divided by cosine. Hang on a minute. Sine divided by cosine, that's actually the definition of tan. So this is tan squared x. And this guy over here, 1 over cosine squared x, well, that's just sec squared x. That's the same thing as we found before. So as we can see, sec squared x is actually just equal to 1 plus tan squared x. So this gives us another way that we could write the definition of the derivative of tan. So we can see that the derivative of tan could be written as 1 over cosine squared x. It could be written as sec squared x. And as we've just seen, sec squared x is actually equal to 1 plus tan squared x. So all of these are perfectly valid derivatives for tan of x, and they are all, in fact, exactly equivalent to one another. Just to prove that to you, if I jump back over here, over to my graph, if I was to, for example, plot the graph of y equals 1 plus tan squared x, that is exactly the same as that blue curve right there. So any of these functions are derivative functions for tan, y equals tan. All right, so that's a fun little video for you. I'm just breaking down the last of these trig derivatives. In the next video, I reckon we might look at why exactly is the derivative of log e of x equal to 1 over x, and in later videos, we'll look at the derivatives of the product rule. So where does the product rule come from? We'll prove that, we'll prove the quotient rule, and we will prove the chain rule. So there'll be some exciting videos coming up. All right, thank you very much for tuning in, and I'll see you guys next time. Have a good one.